This is a D&B story over the last 20, 30 years. It's always a trade between size and wavelength.
We already had the first points that we wanted to improve. Ideally, 2 amplifier channels would be a great deal.
Only putting more drivers into a system, or bigger drivers to deliver only more bass, is just thinking in one dimension.
We did not want to go crazy with the space and with the size of the box, so we had to have a higher density of drivers.
If you want to build that and try it out every time, you're never going to be finished in your entire life.
Well, this did not work from the first moment. We used a few tries there.
The level of modeling tools, of softwares, even customized softwares we've done, helped a lot.
And suddenly the idea came up, why not reversing the principle of the magnetic circuit of an HF driver? And now suddenly this whole thing makes sense.
Yeah, we cracked it.
Well, this is a job that had to be done, and now we're there.
And this is what the SL-Series is about. So, D&B, the GSL systems. Let's have a closer look.
This is a cut view from the top, so open top. Let's add some loudspeakers. Let's start on the front side. This is the side where we want to have the art to get more art on that side and less noise towards the rear. We said give the majority of the internal volume to the low frequency drivers mounted on the front. These are 14-inch drivers. They are mounted in a bass reflex system. So these are the bass reflex ports. So we added some more low frequency drivers, which are 10-inch drivers mounted on the sides. And while they have a smaller part of the internal cabinet volume, separated from the front volume, and bass reflex loading as well. So these are the ports for them. So how to create the dispersion pattern in this low frequency range? The criteria to fulfill this, you need to maintain an acoustical path length difference between the front loudspeakers and the side loudspeakers. That's the reason why we arranged the transducers themselves and the ports in that way, in order to have a large path length difference between the ports and a decreasing path length difference between the cones. Because the lower frequencies effectively take a large arc around the box, while the higher frequencies sneak around the box.
And the optimum is if they arrive here completely coherent and add up the energy.
And that's the additional trick. If you do this right, you can achieve that you get exactly zero loss towards the front, which is exactly corresponding to the same output you would have if these would be mounted on the front baffle as well.
Full coherency.
Full coherency.
Yes.
And that's a good thing for you, because now you can claim we have effectively larger low frequency
16-inch drivers.
Well, it's 16.8. If you calculate it, you can directly add cone area and get the maximum efficiency while having a rejection to the rear.
Full broadband directivity control.
Exactly.
In the LF section. Good. Mid-range.
The mid-range is a pretty common design. It's a 2-slot exit mid-range horn. It gives a bipolar radiation. A bipolar radiation can give a very narrow dispersion, and we can make use of that in the transition, on the one hand, between the low frequency drivers towards the mid-range, and on the other hand, towards the HF.
Looks familiar, doesn't it?
This looks pretty familiar, yeah.
Looks pretty similar to what we've used in the V point source mid-range unit,
Exactly.
where we practiced the design of it, and especially we practiced the industrialization, how to produce it.
It was not so much the simulation and the calculation of that, but it was exactly how to integrate this into a box efficiently.
And that's a capsule driver?
That's a mid-range driver, 10-inch. The whole purpose of that is to keep it as compact as possible and to take away the minimum amount of cabinet volume from the low frequency portion.
Okay. HF, where we need more headroom.
Of course, the first attempt was to optimize this waveguide design.
Optimized for a splay angle between 0 and 7 degrees.
That's the waveguide design. It is optimized for a splay range of 0 to 7, yeah.
Yeah. Okay, a lot of drivers, but how do you all combine that with a specification of only run by 2 amplifier channels?
there are some ideas to bring this together. Of course, we wanted to stay with a low as possible channel count on the amplifiers because as we have array processing as standard, we should not go crazy in the individual box. So basically, we want to drive this from 2 channels of a D80, give approximately half of the available power to the front-facing low-frequency drivers, and give the other half of the power to all the rest. That would be a good match to create the directivity and to share the power in the individual bands.
And of course, the drivers are designed in a way that they perfectly match the output capability of a D80.
That's what we usually do, yeah. Since quite a while, we are matching the drivers exactly to what the amplifiers can deliver, and the other way around. Well, it's okay, so these are assigned to channel 1, and all the rest is assigned to channel 2.
Which is a total of 1, 2, 3, 6 drivers, right?
Exactly. These are passively crossed over.
How does this work?
Possible?
And here comes the trick and the challenge in the design.
That's what we mentioned before. There is this driving function that's needed to create the cardioid pattern on the one hand, and then there's the transition between the low-frequency drivers, the front-facing low-frequency drivers towards the mid-range, where we need a proper alignment to make sure that the dispersion is right in the end. What helps here is that these drivers, the side-firing low-frequency drivers and the mid-range, they are nearly on one line seen from the front. So the distance from the front to here and the distance from the front to the mid-range driver is pretty similar. So this means that the basic time alignment is one common thing. The next thing is that there is a band gap between these side-firing low-frequency drivers and between the mid-range. Why is that? To create the cardioid pattern, you need to fade out these side-firing low-frequency drivers at a lower frequency, then you have to fade in the mid-range. And this means there is a band gap in between, and we can use this band gap to adjust the phase response between the mid-range and the low-frequency drivers in order to fulfill both requirements, to have the cardioid dispersion pattern and a perfect alignment towards the mid-range.
And without that gap, it wouldn't be possible to run it from a single amplifier channel, including all DSP that you would have.
Exactly. Okay. Without that gap, it would be tricky, and it would compromise, well, in the end, either the maximum output towards the front or the dispersion pattern.
And of course, all system drivers are matched to do the same headroom, so that not a single way goes into limit before the others. So that's all absolutely balanced and matched.
That's an important thing, especially on these low-frequency things. They have to have precisely matched headroom and the behavior over level in order to keep a stable cardioid dispersion and to keep the rejection towards the rear stable and not changing with level.
Yeah, that's our balancing work that we do with all systems, sensitivity and balance.
Well, in the end, this means here, of course, this is changing volume share and optimizing driver parameters and everything.
Good. Subwoofers. Basically the flown part of the system in one really nice enclosure.
Okay, let's have a look at the internals of this one. So we added 2 21-inch drivers, and we have a large bass reflex porting in the center of the box. Then the internal volume is shared between this front side and the rear side, where we have an additional 21-inch loudspeaker with some bass reflex porting.
So there's 2-channel active driven.
Again, this is 2 amplifier channels driving the system, and it uses some newly developed 21-inch drivers in order to exhaust the available power from the D80 to the full extent, and to be able to integrate the functionality of the infra and the normal subwoofer into one box.
With enough headroom for any application. Good. Here we are so far for the sub design, cardioid design with a really big step in terms of headroom, and directivity in headroom is what we're going to talk in the next chapter.